Hello, Mr. Barton here, and welcome to another GCSE Maths question of the week, where every week I try my very best to pick you out a beautiful maths question that has been kindly uploaded to my Diagnostic Questions website by the exam boards to help you prepare as best as you possibly can for your forthcoming GCSE Maths exam. Now, this particular question is causing students loads of problems on Diagnostic Questions, so I thought it would be a great one to cover in Question of the Week. And it's been provided by AQA, and it goes something like this. The formula for the volume of a cone is V equals 1/3 pi r squared h. A cone has, now this is nice, they've even made this in bold for us, radius 6 and height 5. Work out its volume in terms of pi. Now, this is the kind of question that you may have been used to seeing in the old GCSE, and indeed, technically, it's not new content. However, I'll say a couple of things about this before we dive in. Firstly, the fact that they've given you the formula is something that you're probably going to need to get used to. Often the formula will be given in the question as opposed to in the front of your exam paper, so that's good news. What's slightly bad news, though, is that these questions, I think, will start to appear on the non-calculator papers more than the calculator. And that's where you get things like this, in terms of pi. So you're going to need to be good enough to be able to work out these formulas without your calculator. But that's okay, we'll be fine. Now, before we get started, wouldn't it be nice if you could actually see what one of these cones looks like? Well, I've blown the budget here on Question of the Week. Where do you see this? There's our cone there. Nice. Okay, right. So what do we know? Well, we know the radius of the cone is 6 centimetres, and our R is going to stand for radius. And the height of the cone is 5 centimetres, so our H is going to be 5. So essentially, this becomes a question of can we accurately substitute into our formula? Well, fingers crossed we can. So what I like to do first is write the formula out. So V equals 1/3 pi r squared h. And now when I substitute in, I like to just put brackets around me numbers, and I'll show you why in a second. So 1/3 pi. Now, instead of r, I know that r is 6, so what I'm going to put there is 6 squared, and then my h is a 5, and it's 5. Now, the reason I like to put brackets around is that for me just emphasises that this squared here, this little guy here, he only belongs to the 6. He's tied to that 6, and that's crucial. That is the fundamental key to this question, making sure you know where that squared belongs. All right, so let's keep going. So let's leave our third pi exactly where it is. Let's see, 6 squared, 6 times 6, I think that's 36. And then I've just got to times that by 5. Okay, so I've got me 1/3, I've got me pi. Now 36 times 5, that sounds a little bit tricky. But what I like to do is times in by 5, and you do this however you want. I like to say 36 times by 10 is 360. And then I'm going to halve my answer, so I'm going to get 180. And if you ever do working out, I like to put it in a little bubble somewhere there. So we've got 180. And now all we've got to do to finish is remember this third. A third times 180. That just means a third of 180, which I reckon is 60. Keep your pi there. You don't need to worry about him. Just remember to include him. And you end up with 60 pi. Is that one of our answers? Whew. Always a good sign when it is. C. So that must be the correct answer. But wait a minute, before you're thinking, right, I'm going to knock off early here. No. Fun's just getting started. Where do each of these incorrect answers come from? Because we can learn so much about those. So A, where would 20 centimetres cubed come from? Well, I reckon there's a chance that you're going to get 20 centimetres cubed if you mess up this squared bit. Imagine you thought that that square bit just meant times by 2. Then what you're going to end up with is a third pi. Instead of 6 squared 36, you're going to say 6 times 2 is 12. Then you're going to have 5 there. And I reckon that's going to give you 12 times 5, 60, divided by 3. You're going to end up with your 20 pi, which is not the right answer. Squared means times by itself. What about B? Where would B come from? 50. Now 50 seems a strange one. Why on earth would you get 50? Well, I reckon you get 50 if you put your squared in the wrong place. So you think that this squared actually belongs here. on your h. And look what happens if you do that. You get 6, and then you get a 5 squared. And I reckon 5 squared is 25, times it by 650, divide it by 3, before you know it, you've ended up with 50 pi. Be careful, it's all about getting this squared in the right place. And finally, D. D is a classic. Where does 300 come from? Well, I reckon if you think this is actually pi r h and the squared belongs to everything, then you're going to end up with this. Watch what happens. You get a third pi, and then you'll do 6 times 5, which is 30. And if you square 30, 30 times 30, 900, divide it by 3, and before you know it, you've ended up with 300 pi. So all those mistakes come not from anything to do with volume of a cone, but because of substitution and knowing your laws of order of operations and all that kind of stuff. Okay? But just before you go, I promise we're about to go, but we're all having a good time here. So what would you pick for your other wrong answer if you had to choose one? Well, the one I was thinking of is this, 180 pi. And the reason I've picked that is a lot of students put so much emphasis on this bit, so much emphasis on getting this 180 bit right, that they only go and forget about the third at the start. And if you forget about the third, you're not going to remember to divide by 3. So just keep in mind every aspect of this formula and just check you've got them all right before you move on. Okay, so if you need help on this topic, my first port of call would be carry on with the rest of the diagnostic questions quiz that this question comes from. You'll find a link to that on whatever page you're viewing this video. And then if you still need help with these volumes and surface areas of what are technically called non-prisms, like cones, spheres, all that kind of stuff, hop on Mr. Barton Maths. You'll find videos, worksheets, all that kind of stuff. And I shall see you for another question of the week next week. Take care. Bye for now.